Determine the equation of the straight line bisecting the angle A of the triangle with vertices having the coordinates A 5, 2, B is 2, 3 and C is 6, 5. Let us begin. So we'll first consider a triangle ABC. Now the coordinates of the vertices A, B and C are given to us. So here our goal will be to find out the equation of the line which is bisecting the angle A of the triangle, meaning our goal will be to obtain the equation of AD. Now to find out the equation of AD, we will be using the 2-point form. Now for using the 2-point form, we need two coordinates of the point that lies on the line AD. So here we have one point A with coordinates 5, 2, but here we are missing the coordinates of the other point D, which is we'll be considering as x, y. So on our first task, we'll have to find out the value of D. Okay, so let's do that. Now since AD is bisecting the angle A internally, what we can do, we can immediately say that the ratio of the adjacent sides, so AB to that of AC, that will be equals to the ratio BD to that of DC. So let this be number 1. Okay, so what we'll do first, we'll find out the length of the side AB. So here what we'll do, we'll be using the distance formula. We'll take the square root. Underneath the square root, we need the difference of the x coordinate. So here we'll do A minus B, which means the difference of the x coordinate will be 5 minus 2. And then we square it. Add it to the difference of the y coordinate. So that's simply 2 minus 3 squared. So this is going to give us the value. So we have 5 minus 2, that's 3. 3 squared, that's going to be positive 9. Added to 2 minus 3, that's negative 1. Squaring it gives us positive 1, which means that the value is square root of 10. Next, we find out the length of AC. So AC comes out to be, we'll take the square root. Underneath the square root, we need the difference of the x coordinates. So we do 5 minus 6, square it, and then add it to the difference of the y coordinates. 2 minus 5 square it. So this comes out to be also square root of 10. Now if we substitute this value back in equation number 1, we get square root of 10 to that of square root of 10 equals to BD over DC. Or in other words, we can say that the ratio BD to that of DC is simply 1 over 1. Meaning D is dividing BC in the ratio 1 is to 1. Okay, now that we have the ratio in which D divides BC, we can use the internal section formula to find out the coordinates of point. All we have to do is take one and multiply it with C, and then the other one will get multiplied with B. Let's apply the internal section formula. So we can find out the coordinate of point D. So that will be, so we have for the x coordinate, we will take 1 and multiply it with the x coordinate of C. So that's simply 6. Added to 1 times the coordinate of point 2, that is 1 times 2 divided by the sum of the ratio 1 plus 1. Now we don't have to actually apply the internal formula. Here it's much easier because D is the midpoint of BC, because it is dividing BC in the ratio 1 is to 1. So all we have to do is add up the y coordinate value, so 3 plus 5, and divide it by 2. This is exactly what we have done in while finding out the x coordinate. All we are doing is summing up the x coordinates of both B and C and dividing it by 2. Okay, so that means we have 6 plus 2, that's 8, 8 over 2, that's going to be 4. Then we have 3 plus 5, so 5, that's 8, 8 over 2, that's also 4. So that means coordinates of point D is going to be 4, 4. Okay, now that we have the coordinate of D, we have the coordinate of A. What we can do, we can use the 2-point form of a line to find out the equation of AD. So let's quickly specify the 2-point form of a line. So if we have 2 points with coordinates x1, y1 and x2, y2, then the line which passes through the 2 points will be given by this particular equation. Okay, so here we have to find out the equation of AD. So here we will consider A to be equivalent to x1, y1 and D to be equivalent to x2, y2. So our equation will be y minus y1. So y1 will be y coordinate of A. That will be equals to, now we need y2 minus y1. That means we'll do 4 minus 2 in the numerator, divided by x2 minus x1. So that's going to be 4 minus 5. So this will get multiplied to x minus x1. So here x1 will be 5. Okay, so we get y minus 2 equals to 2 over negative 1 times x minus 5, which gives us y minus 2 equals to negative 2x plus 10. Rearranging the terms, we get 2x plus y equals to 12. So this is going to be the equation of the angle bisector of our triangle ABC. So here the coordinates of A, B and C were given to us.